Yesterday we talked about the properties of exponents and how you could simplify multiplying powers with the same base, as well as how you could simplify multiplying powers with, or dividing powers with the same base, as well as the zero power. Okay, so we've talked a lot about exponents. We're going to be continuing to talk about exponents today and really looking for a pattern within these exponents to talk about a new component of it for you. So copy on your target, and let's take a look at this table here. So I want you to look for a pattern in the table to extend what you know already about exponents to include negative exponents. We haven't talked about negative exponents yet. That's going to be our new component for today. Start with what you know about positive and zero exponents. So let's think about this. Right now we have 10 squared, and we know 10 squared is really 10 times 10, right? And that is also equivalent to 100. So all of these are equal. Well, if we take that 10 squared and we divide it by 10, right? We divide it by 10, what do we get? You know, we learned these division rules yesterday. This 10 is really a 10 to the 1, and when you are dividing the same base, you subtract their exponents, so this would be 10 to the 2 minus 1, right? What does that give you? What would you have left? Just 10. You could also think of it as 100 divided by 10 is 10. That's the same as 10 to the 1, or 10 times nothing. Well, let's keep going. Let's keep dividing. We have a 2 exponent. We're going to make it a 1 exponent. We want to get these down to become negative exponents to see what a negative exponent really is, what it means. So continue this pattern, guys. If we take 10 and divide it by 10, what's 10 divided by 10? 10 divided by 10, anything divided by itself is always 1. And we know that because 10 to the 0 power, anything to the 0 power is always 1, right? So we're good there, besides 0 to the 0 power. So keep going. Now we're going to take 1 divided by 10. What's 1 divided by 10? Well, you could leave it as a fraction. You could also write it as a decimal. What's 1 divided by 10? 1 divided by 10 is 1/10. Think about how you say that number. 1/10 is 0.1, or 1/10. That's how you read it. Keep going now. If we took 1/10 and we divided it by 10, you can even use your calculator right there if you want. What would happen? We keep dividing by 10 here. Now we have 1/10. What's 1/10 divided by 10, or 0.1 divided by 10 on your calculator? You should end up with, and what fraction is this? Read that decimal. How do you read it? It's 1, and where is that 1 in the place value? This is the tenths, this is the hundredths, so it's 1/100th. Now we're into the negative exponents, so take a look what it means. 10 to the negative 1 means 1/10, or 1/10. 10 to the negative 2 means 1/100th. Can you write it as something times another something? How do you represent 10 to the negative 2? It's actually 1/10 times 1/10, or 1/10 times 10. Hopefully you see how we got there. So, you know, we have the 1/10, we have the 100, we divide by 10, keep continuing to divide by 10 to get into those negative exponents, and we see that these negative exponents are these fractions. So what do you notice? Maybe you could write a rule for 10 to the negative x. How could you always write that? 10 to the negative x would be what? Take a look at what's in common in these two. What's in your numerator? It's 1, okay? So when you have a negative exponent, you're going to move that base. Where does that base move? The base, the 10, where did it go? It actually moved down to the bottom of the fraction. Okay, but then what happened to the exponent? We had a negative 1. This exponent, when you don't see it, is what? It's just 1. This exponent was negative 2. What is this exponent down here? Another way we could write this one would be 1/10 squared. So notice that the numbers are there. They stay the same, but what happened to the sign of that exponent, guys? It became positive, or it became the opposite sign. So 10 to the negative x would actually be 1 over 10 to the x, if that makes sense. And we're going to do a couple of these, so don't worry if it doesn't quite make sense yet. So let's try some of these. If I wanted to evaluate the power of 10, I'm actually going to find the power of 10, but now I have a negative exponent. Remember what that negative exponent means. Let's fill in this box down here first. A power with a negative exponent equals 1 divided by that power. Let me write that again. That doesn't look so good. 1 divided by that power with its positive, or opposite actually, opposite exponent. So 10 to the negative cubed, or negative 30, what would that actually be? To evaluate the negative exponent, remember, this is going to be 1 over whatever the base is. My base here is 10. And then because you moved it down to the bottom of the fraction, it was in a numerator, now it's in denominator, you make the exponent the opposite. So now we just have 1 over 10 cubed. What is 10 cubed? It's 10 times 10 times 10. Which is the same as 1 over 1,000. So this is 1/1000th. You can also write this as a decimal, just reading that fraction. 1/1000th would be what decimal? Again, think about the place values. This first spot is the tenths. It's not 1/10. This second spot is the hundredths. It's not 100ths. The third spot is the thousandths. So there's your decimal. Both of these are answers to evaluating. Okay, both are good. Just make sure that if you are asked for a specific form in your answer, you leave it in that answer. So what I mean is if it asks you for a decimal, write it as a decimal. If it asks you for a fraction, write it as a fraction. If it doesn't specify, you can write either. Now I want you to pause the video and try these next two. Follow the same process that I did on A, and then press play when you're done to see what you got. So pause the video now. Okay, so you've tried B and C. Hopefully your work looks something like this. We should have 1 over 10 to the fourth, and that's really 1 over 10 times 10 times 10 times 10, which is 1 over 10,000, or 1/10,000ths. Tenths, hundredths, thousands, 10,000, so there's your decimal. Here's your answers. The next one, again, because it's a negative exponent, you push that 10 to the bottom of the fraction, underneath 1. The negative exponent becomes positive. That's what a negative exponent means. That's what we saw from the table at the top. So now we can evaluate this to be 1 over 100,000 or 1/100,000th. Both of these answers would be good. So check your work, correct it if you have any corrections. And this rule doesn't just work for powers of 10. So you can do it with any power. Here's another example, okay? We have 5 to the negative third. You're still going to follow this rule. When you see a negative exponent, it's going to equal 1 divided by that power with its opposite exponent. So divide it by the same power. Remember, the power is the whole thing. It's the base with the exponent. But the exponent's going to be the opposite. So we're going to have 1 over 5 cubed. You could leave it like that, or you could evaluate it. If I asked you to evaluate, that would be 1 over 5 cubed is 5 times 5 times 5. What does that equal? 5 times 5 is 25. 25 times 5 is 125. So there's a numerical answer for you to see. You can also write an algebraic example. So b to the negative n, still same rule, a power with a negative exponent equals 1 divided by. B to the negative n is going to be 1 divided by that same power with its opposite exponent. So b to the nth down in the bottom. All right, so let's just remember that we want to always get rid of the negative exponent. If you look on the back of your notes, I have these two pictures here to show you, okay? We never leave a negative exponent in your answer. I want you to write that down. Never leave a negative exponent in your answer. So if you have 17 to the negative fifth, we cannot leave it that way. the least you have to do is at least make it a positive exponent. And that's the way you do that is by writing it 1 divided by that power with its opposite exponent. You may or may not have to evaluate, just always read the directions, okay? So if it says write it as a power, this would be good. If it says evaluate, then you would need to use your calculator to find what 17 to the 5th is. The last part then is what we're going to take what we learned in this lesson, combine it with what we learned in the previous lesson about the properties, and be able to evaluate fully all the way. So evaluating, you got to know what this means. This means actually like solve it all the way out, okay? Don't leave anything undone. So 4 to the negative third, evaluate that for me. Negative exponent, write it under 1. Keep the whole power, but change this to the opposite. Now evaluate it. Now actually solve it. 4 cubed is 4 times 4 times 4. What number is that? 4 times 4 is 16. Times 4 is 64. So 1/64th is your answer here. You don't have to make it a decimal. You can leave these as fractions. Now look at B and C. We're using those rules that we learned previously. So if you want, pause the video, try these two, and then press play. If you're not so sure, that's okay. Just follow along with me. Take a look here. We're multiplying the same base. We learned in section 2.7 that when you're multiplying the same base, you can add their exponents. Keep the base, add the exponents. So what is that going to give you? Well, negative 5 plus 3, negative 5, positive 3, negative answer, negative 2. So we have 2 to the negative 2. We never leave a negative exponent, so we need to keep going. Negative exponent can be written underneath 1. Copy the whole power, change the sign of the exponent. Keep going. You can still solve and evaluate that. So evaluate, take it all the way to the end. We can evaluate 1 over 2 squared to be 1 over 2 times 2, which is 1/4. And the last one here on your notes, the division rules, okay? When you're dividing the same base, we have a 6 and a 6. What was that rule that we learned? When we're dividing the same base, we can subtract their exponents. So this is going to be the same as 6 to the 5 minus 8. 5 take away 8 is going to be a negative number. Find the difference between those two. It's negative 3. Can I stop there? Am I done? No. Hopefully you're saying, no way. We got to get our answer to be happy. We cannot leave a negative exponent, so we're going to have to write it as a fraction. Negative exponent can be written as 1 over that whole power. Change the sign of the exponent. 1 over 6 cubed. Keep going and evaluate that. That's going to be 1 over 6 times 6 times 6. You can use your calculator here, or you can do this on your own. 6 times 6 is 36. And now we have to multiply it by another 6. So if you know the cubes, you might have known that number right away. If you don't know the cubes, that's okay. You can do the multiplication, or you can use your calculator. You will have one in class. So 1 over 216, or 1 2/16. One note here, you might want to write this down. You know you're done when the base is only written once and no negative exponents remain. Then evaluate if needed. So you may want to write that down. You know you're done when the base is only written once and no negative exponents remain. Then evaluate if the directions say to. So here we weren't done because we had a negative exponent. Here we knew we could do something because there was more than one of the same base. All right, you're ready for your quick check.